Well, have you been reflecting on our light lessons this week? Well, that's kind of cheesy. Sorry. Anyway, we're going to talk about that word today, reflection. We're going to talk about refraction. And we're going to talk about absorption. So when we learned these earlier in the year, we kind of found some synonyms for reflection and refraction. Do you remember what they were? What was a synonym? Another word we use that kind of means the same thing as reflect. So reflection, boing. Reflection is bounce. So light bounces off a mirror, okay? And reflection is when it bounces off. Refraction is when it's going straight and then it's bent. So the synonym for refraction we looked at was bent. So reflection, bounce, refraction, bend. And then the other word we're going to look at today, absorb, is when something is absorbed. It takes it in. Think about a sponge absorbing water. Some objects absorb light. Okay? Well, so we're looking at this standard again, and you've got a couple little slides to watch. I put Mulan in there today since we're talking about reflection. That song from Mulan, When Will My Reflection? I just put that in there for fun today, but you do have a little cartoon to watch about reflection, refraction. I think you'll enjoy that. And we've got this text we're going to look at today. So let's read this together. This text, as always, will be on the question set that comes with it that you'll have to do for today. And these are really short questions. We only have 4 for these one yesterday, today, and tomorrow. So make sure you choose the right answer, because if you miss one, you already made a C. So make sure you go back and find your answers in the text. Well, like I said, today we're talking about this. Our title of today's text is Reflection, Absorption, and Refraction of Light. So here we go. You've learned that light is a form of energy that you can see. You can see objects around you because light bounces off them into your eyes. But different objects and materials cause light to act in different ways. When light strikes an object, light travels in a straight path until it hits something. You can draw light as an arrow to show its direction. The pictures below show 3 things that may happen to light when it strikes an object. You'll learn about these 3 processes as you read the lesson. So again, reflecting, you see it's bouncing off an object. Reflecting. Refraction, it goes in and it's bent. Refracting. And absorbing, it goes in and it stays in. It absorbs it like a sponge absorbs water. Reflection. Reflection is the bouncing of light off a surface. When you look at a mirror, the mirror reflects light into your eyes. The surface of a lake also reflects light into your eyes. So do the pages of this book or your computer screen. Any solid or liquid surface can reflect light. That's why you can see the surface. Light travels in a straight line before it is reflected, but it also travels in a straight line after it is reflected, but it just changes direction. You can predict the new path of reflected light. Imagine kicking a ball against a wall. If you throw it at an angle, it will bounce back at an equal angle. Light acts in a similar way. To see how this happens, look back at the picture labeled Reflecting on page 110. We just looked at that. You can see yourself in a mirror because it has very smooth surfaces. Rougher surfaces like this page contain scatter light. They cause it to bounce off in all directions. And then we have absorption. Some light is always absorbed or taken in. When it strikes a surface, what happens to the light? Let me start that again. I didn't read that right. Some light is always absorbed or taken in when it strikes a surface. What happens to light that is absorbed? You can answer that question from your own experience. Your skin absorbs sunlight. As your skin does this, you feel it getting warmer. The more light an object absorbs, the warmer that object gets. Remember that light is a form of energy, and that energy can change form. Absorption is the process by which materials take in light and change it into heat. Objects with dark surfaces absorb more light than objects with lighter surfaces. On a sunny day, you'll feel warmer in a black t-shirt than in a white t-shirt. A black t-shirt absorbs a black shirt absorbs most of the light that strikes it. A white shirt reflects most of the light. So if it's hot in the summer, you want to wear light-colored clothes, right? Compare the temperatures of the 2 boxes in the picture below. It's hard to see, but you can see this thermometer's here, and it's much higher on this one. The white box is cooler because it reflects more light. The black box is hotter because it absorbs more light. When I was little, and told you I grew up on a strawberry farm, and we used to have this old black pickup truck. It was kind of beat up. It was just a farm truck. And there was one day in the summer, I was probably about your age, and it was a hot day. I'm talking like mid-90s. And I was just running around in my shorts. You know, some of you guys do that in the summertime, just got some shorts on. I didn't have shoes on. I didn't have a shirt on. I'd been working outside helping my dad and was just trying to stay cool because it was such a hot day. And it was time to go home. He said, okay, hop up in the truck there. Well, I wanted to ride in the back of the truck and let the wind blow on me. So remember, the truck is black, and I hopped up in that back of that truck with my bare feet and my bare legs, and I sat down and I hollered and screamed and hopped up and jumped out of that truck as fast as I could. Why do you think I did that? It was because it was a black truck, and that black truck sitting in the sun absorbed all that light and had gotten so hot it felt like a stove top. So it burned my skin. Of course, it didn't burn where I had to go to the doctor or anything, but it burned enough to make me jump up and holler and jump out of that truck. So dark objects absorb more light and they get hotter, they get warmer than light objects do. And then refraction. Some materials transmit light or allow it to pass through. Clear plastic, glass, and water are some of these materials. Refraction is a change in the direction of light as it passes through one material into a different material. You can think of refraction as the bending of light. Look at the drawing labeled refraction on the first page. We saw that a minute ago. The arrows show light traveling from the air into the glass and then back into the air. Notice that with each move into a different material, the light changes directions. If you put a pencil in a glass of water, the pencil looks broken. That's because the water refracts light. All right, reflection, absorption, refraction. Reflection, bouncing off. Absorption, soaking it up like a sponge. Reflection, bending it because it's moving from air into water, which is a denser material. Okay. All right. You've got 4 questions to answer on this and some other parts of the slides to watch, a song and a little video about it. Enjoy them and get your work done. We'll see you tomorrow.